Welcome back to Low-Level Programming Crashcasts. I'm Sheila, and as always, I'm joined by the amazing Victor. Before we dive in, if you're enjoying our show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more listeners who are passionate about low-level programming.
Thanks, Sheila. And hello, everyone. We're excited to continue our journey through the Introduction to Assembly Language chapter. Today, we'll be tackling a crucial milestone, writing your first assembly program.
That's right, Victor. But before we get started, I have a quiz question for our listeners. What do you think is the smallest possible assembly program that can actually do something meaningful?
Ooh, that's an intriguing question, Sheila. It really makes you think about the bare essentials of a program, doesn't it? I'm curious to see what our listeners come up with. There are a few different ways to approach this, depending on what we consider meaningful. It could be as simple as exiting cleanly or maybe printing a single character. What do you think, Sheila?
You're right, Victor. It's a question that really gets to the heart of assembly programming. But let's not give too much away just yet. We'll reveal the answer at the end of the episode. For now, let's start with the basics. Victor, could you explain what an assembly program actually looks like?
Certainly. An assembly program is like a recipe, but instead of cooking instructions, we're giving instructions directly to the computer's processor. Just as a recipe has ingredients and steps, an assembly program typically has two main sections, a data section and a text section.
That's an interesting analogy. So, if the data section is like our ingredients, what would be in there?
Great question. The data section is where we declare our variables or constants. It's like setting out all your ingredients before you start cooking. For example, if we're making a Hello World program, we might declare the string Hello World in our data section.
I see. And I'm guessing the text section is where the actual instructions go, like the steps in our recipe.
Exactly. The text section contains the actual assembly instructions that tell the processor what to do. These instructions are written in assembly language, which is a human-readable form of machine code.
That makes sense. So, can you walk us through a simple Hello World program in assembly?
Of course, let's imagine a basic Hello World program for a 32-bit x86 system. First, we'd have our data section where we declare our message. Then, in our text section, we'd have a series of instructions. These instructions would set up a system call to write our message to the console, and then another system call to exit the program cleanly.
Wow, that sounds quite different from high-level languages. Can you explain what these instructions might do?
Certainly. In assembly, we often use an instruction called move to set things up. Imagine we're moving pieces on a game board. We'd move specific values into special spots called registers. These values tell the computer what we want to do, like write this message or exit the program. Then we use another instruction to actually make these things happen.
That's fascinating. I notice you mentioned move a lot. Is that a common instruction in assembly?
Great observation, Sheila. Yes, move is one of the most common instructions in assembly. It simply moves data from one place to another, like from a constant to a register, or between registers. In our example, we're using it to set up the parameters for our system calls. Think of it as putting all the ingredients in the right bowls before we start cooking.
I see. Now, once we've written this program, how do we actually run it?
That's where the assembler and linker come in. Remember when we talked about their roles in our last episode? First, we use an assembler to convert our assembly code into object code. That's like translating our recipe into a language the computer understands. Then, we use a linker to create an executable file. That's like putting all the translated instructions together into a complete cookbook. After that, we can run our program.
That's really cool. But I can imagine there are some common pitfalls when writing assembly. What should our listeners watch out for?
Absolutely. One common mistake is forgetting to properly end our strings or set aside enough space for our data. It's like forgetting to leave room for your dough to rise when baking bread. Another is miscalculating how far to jump in more complex programs. Imagine skipping a crucial step in your recipe. It's also crucial to understand the specific rules for your system, especially when your code needs to work with other programs.
Those are great tips, Victor. Oh, and before I forget, do you have any fun facts about assembly programming to share?
I do. Did you know that the tradition of using Hello World as a first program was started by Brian Kernighan in 1972? He used it in a tutorial for the B programming language, a predecessor to C. Since then, it's become a standard way to introduce new programming languages and concepts.
That's fascinating. Now, I think it's time to reveal the answer to our quiz question. Victor, what is the smallest possible assembly program that can do something meaningful?
Great question. One of the smallest meaningful assembly programs could be just an exit program. It would only have a text section with a few instructions. These instructions would set up and execute a system call to exit the program cleanly. It's small, but it demonstrates the basic structure of an assembly program and interacts with the operating system.
Wow, that's incredibly concise. To wrap up, let's summarize what we've learned today. We covered the basic structure of an assembly program, including data and text sections. We discussed a Hello World program and explained each part. We also talked about how to assemble and link our program and touched on some common pitfalls to avoid.
That's a great summary, Sheila. Remember, everyone, assembly programming is a powerful tool that gives you direct control over your computer's hardware. It takes practice, but it's an invaluable skill for any low-level programmer.
Absolutely. And that brings us to the end of today's episode. If you enjoyed this content, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us keep producing these episodes. Don't forget to subscribe and rate our podcast. It really helps us reach more low-level programming enthusiasts like you.
Thanks for listening, everyone. Until next time, happy coding.